All right, this video is going to walk you through the Chapter 8 test review. What I would encourage you to do first is to try to attempt all the questions that you can on your own first. Then fast forward through this video to help you then get a better understanding of how to do the questions you're maybe more confused on. So here's how we do it. The first thing I want to do is make sure you have two resources. One resource is this one called Polygons Toolkit. There's a link right here if you need the link to get your own copy and print out at home. It's bit.ly GeoPolyNotes. The other note sheet you're going to want to make sure you have is this other one for 3D shapes. It's also called bit.ly and then volume area notes. That will also help you get a copy of this one. This is for the second half of the review. So just to let you know the setup here, two sheets of notes I would encourage you to have, and then let's get started. First thing, question number one. The way I would use this note sheet over here to help me understand these kinds of questions is to first of all look at what are you given. You're given the fact that there are 7 sides, but then it asks the question, what is the sum of the exterior angles? Well, we already know in this chapter that no matter what the shape is, if you are trying to figure out the exterior angles, no matter what it is, it's going to always equal 360. So put 360 in this blank here, and that's what that one will be, no matter what, every time. The sum of the exteriors, no matter how many sides, will be 360. Then it says, what is the name of this polygon? Well, we have a list of notes over here that helps you decide the names of things, and 7 sides is called a heptagon. So you would choose heptagon for that one. Now if you submit that one, hopefully you're successful on your first question. Moving on to number 2, though, it gets a little harder. It says, given a regular octagon, what is the measure of one interior angle? Before we get too far into these things, I just want you to talk about shapes. When we look at shapes right here, no matter what the polygon is, there's going to be 3 mentions to the different parts of the polygon. You got a central angle, that's the tip of the pie piece. You have an interior angle, which is the measure of one big obtuse angle that you see here. And then the outside, where you extend one of the sides straight out from it, that creates an exterior angle. And you're going to notice some relationships. The central angle and that exterior angle are going to always match. So if it's 60 degrees right here, it'll be 60 degrees right here also. If that's 60 degrees, this angle and the interior angle have to always add up to 180 degrees also. So if that's 60, then the interior angle has to be 120 because the interior and the exterior have to equal 180. The other geometry word for that is supplementary. Lastly, then, if you're going to make the extension of saying that exterior angles and central angles are the same, that would also infer then that interior angles and the central angles also add to 180 degrees. Knowing those relationships will make this a lot easier for you as you try to do the different assignment questions. So here's what we do first. The first thing it says is, here's a regular octagon. And I'm going to go back to my note sheet here. And in our regular octagon, which means it has 8 sides, you're then going to figure out the measure of one interior angle. Well, if I go to this note sheet here, what you see at the top of each of these boxes right here is the part your starting point is at. You're starting with the number of sides. I'm told it's an octagon, which means 8 sides. Therefore, I'm going to start with this box right here. I might start out with a central angle, or I might start out with an exterior angle. I might start out with given one interior, or given the sum of all the interiors. Whatever the starting point is, you'll use this note sheet to help you understand how to calculate the part it asks you for. So here's how it works. This one tells you that you have an octagon, so we have 8 sides. Now, if it asks you to find the measure of one interior angle, it tells you the steps right here. It says, hey, take your number of sides and then just divide it into 360. That's what we'll do first. So let's go through the steps and try it on a calculator. So I'm going to take 360 divided by the number of sides, 8, and then I'm going to then get the answer of 45 degrees. And then with that 45 degrees, I'm going to take the 45 and subtract it from 180 degrees. So I'll go 180 minus 45, which then means my interior angle will be 135 degrees. Remembering from the picture of what I'm talking about here too, this central angle that I figured out to be 45 degrees meant it also had to be 45 degrees over here as the exterior. And if that's 45, the interior and the exterior add 180, so subtracting 45 from 180 degrees gave us the 135 that we have right here. So as we finish the question for this part right here, this will be 135 degrees. Next, it talks about a 27-sided polygon. That's a lot of sides. What is the measure of one interior angle? Well, if again, you know the number of sides, let's go to our note sheet here. I know the number of sides and I want to find an interior angle the same way I did the previous one. So let's go to our calculator, do the same thing again. We're going to take 360, let me clear all those here first, 360. We're going to divide by our 27, and then each individual central angle is going to be 13.3 repeating degrees. But now it says step 2, take the angle that you figured out and subtract it from 180 degrees. So I take this 13.333 repeating, and I'm going to subtract that from 180. So 180, and then minus that decimal angle, and I get 166.667. I'll just take the whole thing and paste that into my sheet here now and hope that one works as well. As you can see, we were successful finding the one interior angle given the number of sides. And again, that's using your note sheet of the starting point and then using the directions that tells you how to figure out each of the different pieces. All right, let's go on to number 3. Number 3 is starting you out with a central angle now, so we'll move down here, central angle, starting point, and then it just asks you to figure out the number of sides. That means we're going to just take 360 divided by a central angle to figure out how many pie pieces can fit around the entire 360 circle. If I take 360 divided by 36 degrees, I'm going to have a decagon, 10 sides. Now, if you didn't know the name decagon, you can go to the top of our note sheet here, and the note sheet tells you that, hey, 10 sides is called a decagon. So as you go to the homework now, this will be a regular decagon. Next, it talks about finding the exterior angle of a 90 degrees. So it says the exterior, so that means you have a different starting point. Your starting point is exterior, and it says find the number of sides. Well, again, since central angles and exterior angles are the same thing, take 360 divided by your exterior angle. So in other words then, I'm going to take 360 divided by 90. That means I've got a four-sided figure. Now what was the name of that again? We had a chapter all about these four-sided shapes. They're called quadrilaterals. Hopefully you have that filled in as well. But it would be a square for this example right here. You'll try these other two here where you have an interior angle measure of 120, and then you're going to just go to where it says interior angle, and then it walks you through the steps of how to find the number of sides. And then use the number of sides to determine the name you're going to use from the picture, or from the answer you get for the number of sides. Try the last two on your own. Next question, number 4. This one says you're going to start with an exterior angle, 15 degrees. 15 degrees for an exterior starting point. So you go to your notes, there's your exterior angle. And it then asks you to find the interior angle. The interior angle is as simple as finding by doing 180 degrees minus your exterior angle that you're given. So if I take 180 minus 15, and I'll do that right now, 180 minus 15, and I get an answer of 165. That's all you have to do for these kinds of questions like this, 165. Again, all of this is about you following the directions from your given starting point of the question and then using the directions for what you're trying to find based on what's in the boxes. Again, if you have an exterior angle of 15 degrees and it asks you what the central angle is, hey, wait a minute, remember, central angles and exterior angles always match. So I'll just put 15 in this blank right here because I know the exterior and the central always match. Submit that, and I hope you can get that to turn green as well. Next, as you move on to number 5, it tells you that you have a sum of interior angles that are of a polygon. In this case, 10,440. Now it says how many sides does it have? Well, again, go to the starting point of some of the interiors that you see right here, and then follow the directions for the number of sides. That's over here. Well, it just says take your answer of the total degrees, divide it by 180, and then add 2. Let's try that. 10,440. Let me do that right here. 10,440. Then it says divide it by 180, and then after all that, add 2. And there's my number of sides. It's a 60-sided figure. Well, you're not going to say a special name for that. You're just going to say it has 60 sides, and you would, if you're going to give it a name, you'd call it a 60gon for a 60-sided polygon. Submit something like that and hopefully get yours to turn green as well. Moving on to things like this. You've got to figure out how many degrees total all these x values or these expressions add up to. Well, first I got to know that, hey, I can see this picture. It's got how many sides? 1, 2, 3, 4, 5, 6. It's got 6 sides. And I want to figure out what all these need to add up to. Now, if I do that, I would use this formula right here where I'm starting out with the number of sides, and then I want to figure out what all those angles need to add up to. So that's where I have my number of sides right here, given sides, and find the sum of the interior. Well, that says to do, take your number of sides, subtract 2, and then multiply 180. So I'm going to say, I've got 6 sides, subtract 2, I'll hit return, well that's 4, right? And if I want to, I can go parentheses around that whole thing, and then times 180 degrees. And the answer is 720. That means that all these expressions need to add up to 720. Now, if you want to make this algebra pretty easy for yourself, start by adding up all of your x's. I've got 1x, plus 6 more makes 7, plus 2 more makes 9, plus 1 more is 10, plus 2 more x's is 12, and plus 5 more x's is 17. So I've got 17 x's, plus all the numbers added up. I've got a positive 2, a negative 5. Those would combine and make negative 3. Negative 3 plus 2 makes negative 1, and then negative 1 and negative 7 make negative 8. So if I add up all my like terms, that's 17x plus 8 or minus 8 is what all these expressions here add up to. And they're supposed to equal 720 degrees. So I'll say equals 720. Now as you solve this with algebra, just use your normal solving skills. I would add 8 to 720. So then I would have 17x equals 728. And then lastly, I would divide by 17. So 728 divided by 17 is going to help me find my answer. So that would be your 42.82. I'm just going to go like this. And the 82 stays a 2 because there's a 3 next to it, and it stays then 42.82. So I'm going to copy and paste that in here. And hopefully that will turn green as you solve problems like this. Again, it's about figuring out how many degrees this all was supposed to add up to using your note sheet, and then solving the algebra behind it after combining like terms. Hopefully that helped. Now the next question. This is looking at a central angle of a pentagon. Pentagon meaning it has 5 sides. If you're asked, first of all, what this is called, we'll say it's a pentagon. If you didn't know the name of that, you would go to your note sheet over, let me just get this back here, put back in here. If you were to go to your note sheet, the note sheet would have told you that name of 5 sides. You just go over here, 5 sides, pentagon. Your note sheet will be very useful for you during the test. Next, find the value of x. Well, I need to know what that angle is supposed to be, that central angle is supposed to be when I have a 5-sided figure. Well, go to where you know the number of sides. This thing has 5 sides, and I want to find my central angle. You find it as simple by doing 360 degrees divided by 5. Let's do that right now. I'm going to clear out what we got here. 360 degrees divided by 5. That means that central angle is 72 degrees. Now, if that's 72 degrees, then I need to go to the next line here and say then this expression, 2 times the parentheses, x minus 19, that's supposed to equal the 72 degrees that I have for my angle. That's so you can see it there, equals 72. Then there's a couple ways you can solve this. You could distribute the 2 into the x, or you could simply just divide by 2 to get the x alone by itself. I like dividing by 2. If I divide both sides by 2, 72 divided by 2 will give me 36. So then I just end up getting x minus 19 equals 36, like that. And then I'll just add 19 to both sides, and after I add 19 to 36, 36 plus 19 will give you an answer of 55. So as you get x alone and solve for, this example here says it will be 55 degrees. Hopefully that makes sense on how you solve for x, given the number of sides, to know the central angle being 72 degrees, and then using that 72 degrees equal to your expression right here to get your answer for this one. All right, moving on to number 8. This is a shape here where we have, count the sides, 1, 2, 3, 4, 5, 6, 7. This thing has 7 sides. Whatever shape you have, count up your number of sides for question number 8. And then you have to then figure out, this is pointing at one individual angle. That's an interior angle. So let's go over to our notes. Our notes are going to have, oops, let me get that back. Our notes are then going to say 7 sides, where I know the number of sides, and I want to find out one interior angle. So I'm going to use my calculator to figure out what the measure of this angle is supposed to be when I know that I have 7 sides. So if I go in here and take to my calculator here and go follow the steps here, take 360 divided by 7. I'll do that first here. So 360 divided by 7, and then I have to then take that answer and subtract it from 180 degrees. So then I go 180 degrees, subtract off this 51.4285 and so on. I'll just stop at that amount, but that's plenty. So my answer then for my one interior angle is going to be this, okay? Now this is my decimal answer of what this thing is pointing at. So 7x plus 16 now is going to equal that 128.57, okay? Let me just chop that off too, like this. Well, I'll chop this off right here. Chop those two off, and then I'll say 5.8. You know what? I'm going to leave it like this actually. So it's 5.7. All right, so I've got this right here. Now that angle, I'm going to copy that, and then we'll go to the next line down here. Your 7x plus 16 is going to equal that one interior angle, whatever yours worked out to be as well. Then just solve using your algebra. I would do this one by first of all subtracting 16, so 7x would equal 128.7 minus 16, which would then be 112.8 or 0.57, like that. If you take 16 off that, and then eventually you'll have to take that answer and divide it by 7. So I'll take that answer right there and divide it by 7. And my final answer will then for x will be 16.08. That is how you're going to solve questions like this. Hopefully you can see the steps in the process. Count up your sides, use the notes to figure out the correct number of degrees for one interior angle, set this expression equal to that angle, solve for x, and then you're done. All right, question number 9. This gets to be a little more challenging, okay? Question number 9 is going to ask us to use some SOHCAHTOA skills. Now, it walks you through the steps. I wish this question didn't have so many steps for it because I think it kind of gives away how you do it by just asking each individual question. Now, we just did a pentagon a little bit ago, so I know that if I take 360 degrees divided by 5 sides, because if it has 5 sides given to it and you want to know what the central angle is, that's important for you to know first. And I'm going to go over to my note sheet here now to help us walk through this one. So I've got a pentagon. Let's go over here to this next. All right, so I've got a pentagon. Draw it out again. And my pentagon is going to have a pi piece. Okay? This pi piece is going to have then 72 degrees in the center. And you get 72 by taking 360 divided by 5, or whatever number of sides your picture has. Okay? Now, to finish the question then, I need to try to figure out what the area of this triangle is. The way that works is you want to take this triangle and chop it in half. Now when it talks about an apothem is the actual distance from the center of the polygon to the side. That's this one leg of the right triangle. Your goal on these questions right here is to try to find both legs. The gift for you right now is that you're already given the length of this vertical side right here being 9. Now let's refresh what the different sides are called. This is called the side length, the bottom of that side. That's a side. Okay. This right here is called the apothem. And this last little side right here is called the radius. Okay, you got to know all 3 different names so you know what side you're referring to when it tells you a measurement. Okay. Now, since we know that apothem here is 9, we're dealing with a right triangle, and when I chop this wedge triangle in half, which was originally 72, this will be half of 72, which is 36 degrees. If that's 36 degrees, again, your goal is to try to find these 2 sides. If I know this side and this side, I can find the area of this whole entire wedge really fast by just multiplying these 2 numbers together. Okay, so let's get our calculator going next. So get my calculator out here. Oops. And clear that. Let's try to figure this out. So if I'm trying to figure out this side right here, which I'll call x, then I would look at this as a SOHCAHTOA question. If I say SOHCAHTOA, S-O-H-C-A-H-T-O-A, this is going to then be opposite, straight across from the 36, and adjacent. The only one that deals with opposite and adjacent is TOA. That's tangent. So you're going to take tangent of your angle, 36 degrees, and then you're going to set that equal to the opposite side, x, straight across from your angle, over your adjacent side, in this case 9. Since x is in the top, in this example, you're just going to multiply 9 times the tangent of 36. Let's do that now in our calculator. So 9 times the tangent of 36. Okay, when I do this, the answer comes out to be 6.54. So this answer right here equals 6.54. Now, like I said, if I know this answer of this side and this side, that's the goal of the 2 things of the wedge you're trying to find. So then I'll just take these 2 numbers and multiply them together. Let's do that next. So I'm going to take 9 times the 6.54. Now, I would encourage you on your calculator to not round these numbers, okay? So stay with the exact decimals. So I'm going to use this whole thing that I have right here. I'm going to copy it, and then I'm going to go to my next line down here, and I'm going to use that and then go times the 9. So times 9. That 58 point, so the area of your one triangle wedge like this is going to equal 58.5, we'll say 58.5. And then from that, you're going to then use this to hopefully figure out the rest of the triangle. That was the area of this one wedge, okay? Now, I have in a pentagon 5 of those. So then I take this answer I just got, and then I'm going to take this 58.499 and so on. I'm going to take that, and I'm going to go paste it, and I'm going to go times 5 because I have 5 sides. Now, if yours has 6, multiply it by 6, whatever you got. And then in this case here, I've got my final answer for my total area of the pentagon, which would look like this, right? That's going to equal the total answer of 294.25, we'll say. Close enough. All right, and then using that information, hopefully when you go to the actual question, you can fill the things in. So let's fill it in right now. So I've got a central angle of 72. I've got a half angle when I chopped it in half. When I chopped it in half, it became 36. That goes in this blank. Then it talks about a height of the triangle. Well, the height of the triangle is already given to me. That's 9 from the apothem. Then it talks about the base angle, or the base of the triangle. Now, this question, the way it's set up here is they want to know the length of the entire side. So if this side right here was 6.54, I have to double that, which would then be 13.08. Let's try that. Let's see if 13.08 works. 13.08, because I have to have 2 of these to complete the entire base of that wedge triangle. Then from there, it also asks for the area of one triangle. That's where we did this right here. We did that 9 times the tangent of 36, which gave us the answer of 58.5. That will go in this blank right here, 58.5. And then the last thing is we're going to go and get the area of the whole polygon, which is 294.25. And as you submit this one, I hope your answer also works. Whoops. Hopefully your answer works out as well. Does it turn green? It did not like one of my answers, it looks like. The base of the triangle. Back when I was going through that one side length of 6.53, it wants to be a little bit more exact. This was the exact length of that half side right here. I'm going to take that now and double it. So let me go do that right now. I was wondering if that was going to be an issue. So that could be for the same issue for yours too. So I'm going to go double that length so I can get the length all the way across here. So I'll go times 2. Our answer will be close, but it wanted it to be more exact than it was. So it wants to go, oh, it does say 4 decimal places. So we would put the 0.0778, so 778 like that as well. And that's what we did have, if you remember. 0.0078 is what that would round to in here. But use your decimals as you're noticing what I'm doing right here. So this doesn't happen to you on the test. Make sure you follow the directions for the decimal places you need to put your answers to. But hopefully at least you saw, we start with the picture, use your number size to find your central angle, which was 72. We chopped it in half to get 36. Our goal is to try to find both sides and then find the area of one triangle by multiplying those together. And then when you had the area of the one wedge triangle, then you multiplied it by the number of sides, and that gave you the total for the entire polygon. Hopefully that helped. Now to get to this question right here, you got a circle. If you're going to try to find the area of that circle, very straightforward. Down in the note sheet right here, it talks about areas of circles being right here. It's pi r squared. Now, when you use your calculator, make sure you find the pi key. Don't use just 3.14. Use the entire decimal. Now, as we go through this question right here, get my calculator back here. I'll bring it back to this side. It's pi r squared. So when I go to this question right here, I'm going to take pi. So I go pi and then times the radius squared. Now the radius is always the half distance. What we're looking at right now is the diameter all the way across. The radius is just half. So we're going to take pi times 6 and then we're going to square that. This will be your area of the question. So if I copy this right here and paste this one in here, it does say 2 decimal places. Here's a one we have to kind of be careful with how we paste or how we round it. 2 decimal places means that 7 is going to make the 9 turn to a 10. So you have to carry the 1, which then makes this just become 113.1. Seems kind of weird. If you do put the decimal places 3 places, I believe it'll still mark it right. But that's how you do the first one. Hopefully you can get that first one correct. Now it also asks for the circumference. That's your distance around the circle. The distance around the circle is going to be found by you trying to go through, let's go right here, this formula right here. You have 2 options. You can use pi times diameter, or you can use 2 pi r. Now if you want to do pi times diameter, that's really easy to do with the calculator. Let's just do that right now. As you try to solve this one right here, you'll have 37.699. And then as you round this one correctly, it'll be, this 9 makes that 9 turn to a 10. You carry the 1, so 37.7 will be the answer to that one. Hopefully it's not too difficult to get you through these area and circumference. Again, follow the directions for the number of decimal places so you don't get marked down for not having it out and accurate enough. Now as you go to number 11, this one talks about the area of a circle being 36 pi. Now you know the formula for area. It tells you on the formula sheet, as you look at the thing for this right here, area of a circle is pi r squared. So the number next to the pi that you're seeing right here is a result of the radius getting squared. So what number do you square to get 36? Well, that's pretty easy, just 6. So this is how you solve these kinds of questions. Look at the formula and decide what does that number next to pi need to be to create this expression for the total area of the circle. If it's pi r squared, some number got squared to give you 36. If you were just to square root 36 on your calculator, that also would give you the 6 as well. Hopefully not too difficult to see that. Next, we're going to start looking at prisms. Prisms are these kind of shapes that have matching parallel and opposite shapes. Now this is a triangular base pyramid. We have a rectangular base pyramid. So this one actually has 3 pairs of bases. You could do top and bottom as bases, I could do front and back as bases, or I could go left and right as bases. You have choices. The one that's shaded in there is what they're trying to point to and help you decide what you want to make as a base. So we'll use the 18 by 10 base. Now using the formula right here, this formula is your jackpot to trying to find the answers to these questions. Understand that you have to find 3 things. You got to find the area of the base, the prism height, and also the base perimeter. 3 things. Area of the base, prism height, and base perimeter. So as you're going through question number 12, let's find the area of that base first. The area of one base is as simple as going 18 times 10. 18 times 10 is 180. But if I'm going to go 2 of those, I'm going to have then 360. So 360 is the answer I have for my question. Now whatever you have, multiply this number times this number, and that'll be the area of one base. But if you do the bottom and the top as your 2 bases, you're then going to have a total area of the bottom and the top, in this case being 360 for me, and whatever you get for yours. Also understand that as you're trying to find surface area, which is what we're leading ourselves towards, you're then going to have to take the perimeter of the base. Now, the perimeter of the base is just a matter of you adding up the sides around the bottom of this rectangle. So I'm going to go to my calculator here. I'm going to add up all my base values. So if I'm going to find the perimeter of this base, I'm going to go 18 plus 10, 18 plus 10, plus another 18 over here on the right, so 18 again, and then plus another 10 that's in the back, so plus 10. Now I've got a total perimeter of 56. So now I'm going to go back to my formula sheet here and figure out how to find the total surface, or the lateral surface area. Remember, lateral surface area is the perimeter of the base that I just figured out, which was again 56, and then times the prism height. The prism height is always the distance between the 2 matching bases. If our base is going to be the bottom, then the matching one on the top will be the matching base also. The distance between your matching bases is your height. So that means the height is 27. So I'm going to take 56 times 27, and that will equal my lateral surface area that it's asking for. So as I do that one right there, let's go back to the calculator and multiply our perimeter of our base, which is 56, and we're going to go times 27. Hopefully not too difficult. So that's going to be 1,512 for me. Hopefully your answer also works out nice for you too as well. So then for this part right here, put that answer in right there. Last thing we have to do is find your total surface area. Now the formula, if you look at this right here, the sheet says take your 2 bases, that's what you see in red right here, plus your lateral surface area, and then add those together. So if I just take 360 plus 500, or 1,512, that will be my answer then to this next part. So I'm just going to like this. And I'm just going to add my 360 that I had for my 2 bases, so plus 360, and then I get 1,872. That will then be your total surface area. Again, if you're wondering where that 1872 came from, that came from me taking 2 times the area of one base, that was 180 for my picture, which made 360, plus the perimeter of my base, 56, times the height, 27, to give me a total surface area of 1,872. Lastly, we want to try to find the volume. Using your volume formula for prisms, you're going to take the area of your base, which for us, or for me, is 180, times my prism height, 27. So I'll go to my calculator and take 180 times 27. That's my total surface area, my total volume of my shape. So whatever the volume units are, it's going to be cubic units of whatever I forgot, okay? Submit your question, hopefully you get that to turn green. All right, now as we move on to number 13, we're going to be looking at what is a cylinder. This cylinder has a formula that you're going to see in your note sheet as well. This cylinder sheet is going to have volume equals pi r squared times the height, and it also has surface area being 2 pi r squared plus 2 pi r times your h for height. In cylinders, you have matching bases, which are your circles, and you're going to then find that there's a distance between those circles. That's always going to be your height. It's not always vertical. It could be this thing could be laying down on its side, but whatever distance you have between your 2 circles, that's the height of the cylinder. All right, so now as you look at the picture right here, there are only 2 letters you need to figure out, the radius and the height. That's the only thing you see for this. Obviously, there's a pi there too, but the pi is a number 3.14. And when you use your calculator, don't use just the decimal 3.14. You have to make sure you're using the pi key or using pi on this online calculator that we're using here today too. So let's go through this now and try to figure out each piece. If I want to try to figure out this first question, it says find the area of the two circles. Now in the formula sheet, you know that you have oops, not this one. You have a sheet that says circles are found by, the areas are found by doing pi r squared. Now that's what this is also trying to tell you here. This part of the formula for finding the area of two circles is just a matter of you doing 2 pi r squared. So go to your calculator and then just go into, type in the letter pi, and then it makes the pi symbol show up, and then put in times your radius. Now this 16 is not your radius. That 16 is your diameter. Half of that is your radius. So I'm going to use 8 for my radius, and then it's going to be squared. All right, now moving on. From here, you're then going to have the area of your two circles. So just copy and paste this into your blank. What will also help you during the test is to make sure you do one blank at a time. You don't want to fill this all in and get them all wrong in one try. You are able to submit one part of this at a time. So make sure you have this one as this 402.12. That 3 does not make the 2 change, so it just looks like this. Submit what you have right now so far, just to make sure you're on the right track. So I just found the area of both circles. And again, using the formula sheet helps you figure that out by just doing 2 pi r squared. When it asks for the lateral surface area, we're going to use this part of the formula, where you just do 2 pi r times the h. So let's do that right now on the calculator next. So 2 pi r times h. Let me clear that out. Oh. I'll go 2 pi r, so 2, and hit pi r. My radius is 6, or 8 in this case right here. And then to finish the formula, then it says times the height. 2 pi r times the height. And the height of this is going to be 40.7. So times 40.7. So I get an answer of 2045.8. We'll say 81. I'll paste it here first, and you'll see what I'm talking about. And that's the lateral surface area. So now when I round this correctly, that 0 should change to a 1. And now I've got my answer to this one. Checking things as I go along is very smart to do. And then this is the two parts of the formula that you're looking at. So if I go back to the note sheet here, this is the lateral surface area, that's the surface area. The total surface area is you adding both of those answers together. So if I go back to my calculator, and I take this answer right here, and then I'll go the next line down. I'll take my lateral surface area plus my two circles, which is this one right here, and we'll put those in the same window, and this is what they look like when they're added together. I get this for an answer. But when I round it to 2 decimal places, it will be then a 9.3 for me in this example. So hopefully when I submit this, I'll have all my surface area figured out so far, which is awesome. Now the volume of cylinders is actually not that hard to figure out either. Go to your formula sheet for volume, and it just says take pi r squared times the height. Well, your radius, again, is just 8, and then your height is 40.7. So I'm going to go pi r squared times the height. Let's try that next. So pi times my radius, which is 8, pi r squared, I should say, pi r squared, and then times your height. Your height, again, in this question is 40.7. So 40.7. This answer is representing my volume for the question. So we'll take that, we'll put that in here, and hopefully you're successful finding your volume and surface area of cylinders. Again, use the formula sheet. That'll definitely help you get through the cylinder parts of this question. Next, what you see here is a pyramid. Pyramids are on this shape right here, and pyramids have two formulas also. We just got to figure out, first of all, what is the area of your base and what is the length of your height. Now this is a weird looking kind of pyramid. It's like one little, the apex or the tip of the pyramid has been pulled over directly above one of the corners of the base. It does not matter where that tip is at, as long as you know how high it is to the base of this pyramid, it does not matter. It makes it look weird here, but we'll figure it out from here. All right, so the first thing it asks you to do is try to figure out the height of the pyramid. Well, the height of that pyramid is simply just 21 to the tip of the actual pyramid, so it's going to be 21. Next, you're going to notice that there's an area of a pyramid on this one as well. The area of the base of this pyramid. If you're trying to find the area of the base of this pyramid, you're simply going to take 12 times 12. Well, if you know your times tables, that's really easy. That's going to come out to be 144. Again, if this is a test, submit parts of it at a time so you know you're not making any mistakes along the way. Lastly, if you're trying to find the area of this pyramid, or I'm sorry, the volume of this pyramid, you're simply going to take 1/3 times the area of your base times your height. We've got all the information right here for you to set up to do the calculation. Let's try it now. So I just said it was 1/3, so 1 divided by 3 times the area of your base. in this case right here, which is 144, and then times your height of 21. That's all there is to questions like this, and that will be your volume of this pyramid. The surface area actually would have been a little more tricky to go through a question like this, but hopefully you're successful going through your question as well. Now for cones, this one's going to ask you for a couple things. It's going to ask you for the lateral surface area and the volume. Let's go to the formula sheet now and look at what that looks like as you go through this one. So cones. Cones have the same kind of formulas. Anything that comes to a tip is going to have a volume that's always 1/3 as opposed to just area of your base times your height. So it's 1/3 the area of your base times the height whenever it comes to a tip. All right, let's figure out this one right here. So it says the slant height. Oh, we need to talk about some pieces of here. So let me go to my note sheet here too as well. So on the note sheet, if you're ever looking at parts to a cone, it says it on the note sheet as well, but when you're looking at a cone, you're going to always see a right triangle that's formed inside the cone. And it also happens on pyramids as well. This distance right here, from the center of the circle to the tip at the apex there, that's going to be your height. That's just your normal height of a cone. But when it talks about slant height, that's your hypotenuse of this right triangle. So this is the slant height. I'll abbreviate it with just an S and an H. And that's what it's referring to here. So when it asks you to find the slant height, on this picture here we have a right triangle. In this right triangle, when it's on the side like this, you know this length is 12, and you know this length is 5. To find this slant height, you're going to have to figure out the Pythagorean theorem. Don't forget it's a squared plus b squared equals c squared, and the length of this x value, or your slant height is going to equal the square root of these two legs added together. So 12 squared plus 5 squared. Let's go to our calculator now and figure that part out. 12 squared plus 5 squared and square root that. Real quick, this should not take long to do, hopefully. So if I go square root SQRT, oops, get this in here first, SQRT, and then we'll put in 12 squared and then plus 5 squared. And the nice thing is in this one, it's going to actually work out nice. You get 13 for the answer. So our slant height is 13. Us unlocking this makes this problem a lot easier to do. So now let me go back to my note sheet here that I'm showing you like here. And then now I've got a slant height that equals 13. Now, using the formula sheet, knowing that slant height is 13, we'll put it in the blank here too. And on the test, like I said, submit it one part at a time. You'll know how to get through those kinds of questions. The area of the base. Now the area of the base, let's go back to the formula sheet again. The area of the base is found by just doing pi r squared, or just the area of a circle. Your circle has a radius of 5. So that means if the radius is 5, I'm going to go pi r squared. Let's do that right now. So pi r squared means, clear that out here. So I'm going to go pi times my radius being 5 here, and then squared. And then what I then end up getting then is the area of the circle, pi r squared. That would then be this decimal to put in my blank here too. I'm going to copy that real quick here and put it here. But it does say round 2 places, so that 9 makes that 5.3 turn into 5.4. All right, that's my area of the one circle. Now, keeping things moving on, when it talks about lateral surface area, you go to the note sheet here. The lateral surface area is this part of the surface area formula. So you're going to take pi times the radius times your slant height, which we determined was 13. So let's go through this next part. Go to your calculator, and you would start then by saying pi times your radius of the circle, and again, that is, in my problem, 5 for my radius. Let's go back to the thing here. Pi r slant height. That will then be the correct answer. But now the 3 makes that then just stay 320, and you don't need to put zeros at the end, so it's just going to be 204.2. Again, now we're feeling pretty good about our surface area. From here, your lateral surface area then is, or the total surface area, is you adding both of those two answers together. So if I take, in my calculator, take this 204.2 and go next line down here, and then add with that the other one, the 78.54, and then I'll have my total surface area at this value right here. You're adding the circle area and your lateral surface area to get a total answer of 282.74. Hope that makes sense of how you got the surface area. Lastly, the volume. Go back to your formula sheet. Volume of cones is found by doing 1/3 pi r squared times the height. Let's try that again. So in here, I'm going to go volume equals, get my calculator here. Let's clear this out too. 1/3 pi, and then we'll go radius. In this case, your radius of the circle again is 5. So pi r squared, and then times the height. The height is how far it is from the center of the circle up to the tip. In that case, it's 12. So that would be your total volume of the shape. Does that look familiar? 3.14, oh, not, it's basically pi. Can you see that? That's kind of weird. Hopefully you're seeing something that's kind of neat here. It's not pi like 3.14, but it's 314.159. And if you're a math person, you can recognize that 314.159 as pi with the decimal place moved 2 places to the right. But if we round it correctly, it'll turn into 1/6. And hopefully submit that one, and hopefully you have your volume as well. Mine was a special answer. Maybe yours won't be, but that was kind of cool. All right, now you've used the formulas for cones. Again, 1/3 pi r squared times the height. And then for surface area, the question was broken down into 2 parts, which then eventually you added together to get your surface area. All right, we're coming down the final stretch here. We got spheres. Spheres are looking like this. Spheres, you just need to know the radius, and that's it. There's no heights, there's no slant heights, it's just radius. This is a volleyball with just the diameter given at 35. So if you're a person that needs a calculator, you could go 35 divided by 2, and you get an answer of 17.5 for your radius. All right, now we're going to take that and we're going to use the formula for, what does it say here? It says find the surface area of the volleyball. Let's just go straight to the formula and then transfer it over. Surface area for a sphere is 4 pi r squared. So I'm going to go 4, hit pi, and then paste that number in there and then squared. That's 4 times pi times my radius squared, and this is my surface area for the circle. Okay? 4 pi r squared is how you find sphere surface area. Okay. Next, for volume, let's go back to the formula for that one as well. That's going to be 4/3 pi r cubed. It's kind of like 4 pi r squared, but now it's 4/3 pi r cubed for the volume. We'll do that next. So if your radius is 17.5, we're going to go 4/3 pi and then times your radius. In this case was 30. Oops, that's not there. Is 17.5. And then we're going to cube that. And I get a final answer of this. It's pretty big, and that's my volume of this volleyball in cubic centimeters. Quite a few. It's a lot of cubic centimeters. And then in this case, if I round it correctly, that 7 would make the 9 turn to a 10, which carries the 1 that makes that then 0.3. All right. Hopefully you got through your question for your volume and surface area of a sphere, in this case a volleyball. It was important to recognize, though, that it gave you the diameter, not the radius, so you had to chop that in half. As I'm looking at a question like this that has different ratios, I've got a linear ratio, an area ratio, and a volume ratio. I would encourage you, when you do problems like this, is just write down L, A, V. The best way you can understand this is that the L stands for linear measurements, A stands for area measurements, and then volume stands for volume ratio. The V stands for volume measurements. Whenever you're going to measure something in inches, you would just use inches to measure out how long or the length of something. If you're going to use units for area, you would say inches squared or square inches. If I want to talk about volume, I would talk about cubic inches. Understanding this about the units will help you understand how to convert these different ratios. Now, if I talk about the first ratio being 3/13, 3/13, if I want to change 3/13 into a ratio with area, the only thing you'll notice is that if this is 3/13, that's like 3 inches over 13 inches, and I want to change it to an area ratio, all I have to do to those units is just square them. So I would just square the 3, and I would square the 13. When I do that, I get 9/169. Knowing your times tables will help you do that kind of question as well, but this next one for cubing is a little more difficult to do. Again, if you know the inches and you want to change it into volume, all you do is you take your inches and you would cube it, right? So if I just take these measurements that are here, I would cube those things and do 3 cubed over 13 cubed. Now, let's put that in the calculator so we can actually see what that looks like here in this case here. So I'm going to pull up my calculator and do 3 cubed over 13 cubed. So 3 cubed looks like this. And you can go like this. Well, you know it's 27, but if you want to write it as a fraction, you can do that too. So I'm going to go 3 cubed over, and then I said 13, and then I'm going to cube that as well. That's one way to do it. And then if you hit this little fraction button, math, enter on your graphing calculator, or the F to D on your scientific calculator will get you the fraction for this right here. Now, if your calculator can't do that, I would do them individually. What I would have done separately then is just go 3 cubed like this, hit enter, and then just do 13 cubed and hit enter. And that would be another way you can break this up into separately as a fraction as well. If your calculator can't turn it into fractions, just do them one piece at a time, and you'd still have 27 over 2,197. Let's write those answers down now. So I've got 27 over 2,197. And then the other fraction, which we said earlier, was 9 over 169. And again, you could just do those squarings of the 3 over 13. Those are really easy. I've seen a lot of students have success filling these ones in. Now, what makes it more challenging is when you start out with an area first. So let me go back to this right here. If you have an area measurement that's in squared, inches in this example here too. If you want to take something that's being squared and get it to turn back into linear values, to get rid of a square, we know that if you're solving an equation for x, if it's x squared, the way you cancel that square is the square root, okay? So if I know that I've got a 121 over 169, I know that if I square root this and square root this, that'll take the square that's off those units and turn it into a linear value. In that case, then you would have this getting turned into 11 over 13. That would be your linear measurements, okay? Because to get rid of a square, you have to do the opposite of squaring, which is the square root, which turns into a linear ratio of 11 over 13. Now that we know this, we can then change our linear one the same way you change the other one by cubing the inches to get it into inches cubed for volume. Just like you did in this one right here, you did 3 over 13, and you cubed those values to get it as 3 cubed over 13 cubed. So we already know what 13 cubed turns into. I've got it on my calculator still, I believe. And then I need to turn on what 11 cubed is. So I'll just change that first 3 in my calculator here to an 11. And as you cube the 11, you get 1,331, and the 13 cubed turns into 2,197. So when I go back to my calculator, or my written answer here, I'll have 1,331, and then, let me write it down here, 1,331 over the other answer, which is 2,197. So you had to get this second box by simply finding the linear one first and then cubing it to get over to this side. So as you finish filling this in, hopefully you can get that filled in. I'll do it right now too. So 11 over 13. And then this one over here then turns into 1,331 over 2,197, like that. And if you submit that, hopefully you get green on those two. Now the hardest one is this one right here. We're going to talk about that next. So as you start with this last one, I'll make a different color here. If I do this last one, I'm going to start out with 27 over 729. The question about this is now this is a ratio that's given to you in volume, and volume is always measured in the units being cubed. Now if you're going to get rid of something that's being cubed, just like when you had something getting squared, if you have x cubed, how do you get rid of the cube? And that's by you doing a cube root. That is a challenge for some of you on your different calculators. If you're using a graphing calculator like this, a graphing calculator, if you're going to do a cube root of, for example, let me write it out here first. We're going to try to cube root the 27. So if I cube root that, we're going to do a cube root of the 27, and we're going to do a cube root of the 729. The way you do that on a graphing calculator like this is you're going to find that there is a, under the math key, you're going to do it right here, you're going to go type the number 3 first for the cube part, go math key and then press 5. That'll put the 3 in the corner, or you might have an older calculator that'll just say 3 and then there'll just be an X and a root symbol. And then from there you'll get the, 27, putting in the blank here, and the cube root of 27 is 3. I'll do the other number as well, which is the 729. We'll do the same thing again. We'll press 3, press math, and then option 5, and then put in the 729. That means then our ratio turns into 3 over 9. It does say in the directions here though, however, if I've got 3 over 9, I need to reduce that fraction. 3 over 9 reduces down to what? 3 over 9 reduces down to 1/3. Okay? Now, what I want to do next with you is show you how you could use the graphing calculator, or the online calculator here. So the cube root is done on here by doing, so if we're going to do the cube root of 27, I go through, first of all, press this little button right here that says the n root, and you're going to put a 3 right here, and then put 27 in the blank right here, and that gives you the 3. And then if I want to make it as a fraction, I can do the same thing again. Put the n root with a 3 there, and then put your 729 in that other part. And this will already put it into the form of a fraction for you, and that's why it's also going to be 1/3. So I have a 1/3 right here, so 1 over 3. Lastly, I just want to make sure I get this down to a fraction. that is going to be then the 1 squared and the 3 squared. 1 squared over 3 squared turns into 1/9. You square both the 1 and the 3 to get this area fraction to get from inches to inches squared. So you square the numbers to get that value as well. Hopefully that wasn't too hard to do, and hopefully you have that filled in. We're on our last question. Woo! I want you to write down LAV down again. This is really easy to do. So put LAV down on your paper. LAV. Remembering again what we're talking about. This is inches for length. Think about inches squared for area and then inches cubed for volume. As you fly through this last little part right here, you're going to notice it says you got two figures in a ratio of 1 to 4. That's a linear ratio, 1 to 4. Okay. Then it says the area of the bigger figure is 240. So that 240 we put under the area blank. Okay. So I put that under the area blank. That would go like this, and it says that that is a bigger value, which is the lower part of this fraction, because 4 was the bigger number there too as well. So I put 240 right here. Now, if I want to make these fractions equal to each other, they're not equal because one's in inches, one is in inches squared. So what would you have to do to one of these units to get them to be the same? You have two options. You could try square rooting this to get down to inches, which then makes a mess because you got a square root around the x. We don't want to do that. We would want to square the inches so that they could be both inches squared and inches squared. So we're going to square both these two numbers right here. By doing that, you're finding the area ratio, which is what it's asking for right here. So if I square 1, I get 1. If I square 4, I get 16. This right here is my new area ratio in inches squared. That goes in my first blank right here as 1 over 16. All right, and then the last part then is we're going to solve this proportion by simply cross multiplying. Since they're now both in inches squared, and then I go and then multiply it out. So I go 240 times 1 squared, 240 times 1 squared, which you already know the answer to, but I'm going to write it out anyways. And then divided by, all that getting divided by the what's across from the x, which is a 4 squared. So 4 squared, which we already knew was 16 as well. So our final answer for my question, when I do the cross multiplying of 1 squared times 240 and then divide by what's across from my x, which is 16, I get a final answer of 15 for x. And that is my final answer to the question and my last area I was trying to figure out. Hopefully, this helps you get through the full test review. Thank you for working and patiently with me on this question right here and getting through the whole entire review. You've now seen all the questions, and I really hope this video helps as you try to get ready for the test.